So, hello guys, welcome to my YouTube channel Data Stories. So, in the last class, we have studied the practical implementation of logistic regression. So, in this video, we are going to learn a new machine learning algorithm that is decision tree. So, let's start. So, decision, and one more important point while I am making the notes, your concentration should be on the video. After I complete the whole video and you understand the concept, then make notes. Notes are the most important thing that you should make. Okay. So decision tree is a supervised machine learning algorithm. It can be used for both classification as well as regression task. It can be built on binary and multi-class also. So it's an supervised machine learning algorithm. What is supervised machine learning algorithm? Supervised means label data and it can be divided into train and test algorithm. It can be built on binary and multi-class also. Logistic regression, it's only built on binary, but in decision tree, it can be built on multi-class. Okay, so it can be built on binary and multi-class. And the third most important point is that if we make logistic regression, right, there we can build decision tree. But if we make decision tree first, then we can't make logistic regression. So wherever we build logistic regression, we can build decision tree, but vice versa is not possible. Is not possible. So now I will show you how decision tree work. I always prefer an image that nicely explain the concept. So I will show you that image. If this image is visible for you, I will show it up. Okay. So as you can see that if the tree is predicting if a person is fit or unfit. So it has a lot of parameter in it. Each node has its own parameter, right? First it is checking. This is the first node, right? This is second node, this is third node, and they are predicting. Okay. So if the age is less than 30, it is saying yes. Then another condition. If he or she eat pizza, if yes, then he or she is unfit. And if no, he or she is fit. So if age is less than 30, yes, he is fit. And if he doesn't eat pizza, no, then he is fit. So yes and no. It's going like this. It's checking multiple parameters. Same goes to the other side. If age is less than is if age is greater than 30, no. Then another condition. If he is doing exercise, then yes, he is fit. No, yes. And if age is greater than 30, no. he is doing exercise, no, then he is unfit. So this way the whole decision tree works. Hope you understand the concept. So if all the variables are not of same important, then we need to check the most significant variable first. Okay. So that's all the image explains about. In decision tree, decision is based on tree. Whichever parameter or condition is most important, that should be checked first, and then the second one, and so on. Okay, just I will open the image. So as I've said, whichever parameter or condition is most important, that should be checked first, and then the second most, and so on. Same goes in this image, as you can see that if age is less than 30, we are checking first condition, then second condition, and so on. If the tree is big, we may have more nodes, and the parameters are also more. So to decide the parameter, we use entropy and Gini as the evaluation parameter. So we will see entropy. Entropy is randomness, amount of how randomly your data is distributed. So in simple word, I will write here randomness. And Gini, and Gini, and Gini. Gini is also called Gini is also called Gini score. For example, well distributed. You know that some people have a lot of property, and for some people, for example, I will take the law rule, right? For some people, the law is different, and for some people, the law is different. For example, if I am a VIP, right? So for me, the law is different, and if I am the kind of middle class person, for me, the law is different. I can't give here the example, otherwise the video will be copyright. Okay, so for example, I will write law for VIP are different, and for middle class is different. So this is Gini. So the formula for it, entropy. I will open paint. So entropy. Entropy, the formula is summation of minus p log to the base, log to the base 2, and this is small p. Okay, the big P, the big P, this P is sample probability, and this is population probability. Okay, so I'm not going into the depth of this concept as we are focusing on covering the practical implementation. So if you want to go into the depth of this concept, you may prefer some other video. So now Gini, Gini score 1 minus summation of small p I whole square. So these are the formula for entropy and Gini. So so if entropy is more, then we take the first node. And if the Gini is least, we take the first node. These are the two important points. If if entropy is more, we take first node. If Gini is less, we take first node. Okay. So by default in decision tree, we use Gini. So by default, decision tree, we use Gini. Okay. So if we use Gini, right? If we don't get the accuracy good, so we may try some other, like we may try entropy. So it's our hand. These are called hyperparameter. So hyperparameter. So we don't know which combination of the parameter would give us the best model, right? So we try different parameters. Like first we try Gini, then entropy. Okay. So hyperparameter. We don't know which combination of parameters will give us the best model. Okay. For example, I can give in real life example radio. Okay. So while you are traveling in a car, for example, and you don't know which kind of radio frequency will be the music that you want to listen, right? For example, 93.5. You don't know 93.5, you can hear the audio. So you tuned it. First you check 93.5, then 93.2, then 93.3, then 93.4, and you get then 93.5. You get the clear audio. This is called tuning. You tune it to get the best audio. So this is the example of hyperparameter. So that's all about this video. In this video, we have covered decision tree theory part. In the next video, we will cover the practical part or somewhat more theory part if it is remaining. So thanks for watching this video. I will see you next time.